Hey, physics fans, happy snow day. If you're happening to do physics today, here's a little bonus for you, or whenever you do this, little hints. Because 8, 9, and 10 on the review sheet are just a little bit harder than anything I would ask you on a test. And it's only when you feel pain that you grow. So these are hard. It's growth moment. Okay, I'll help you get started. 100 Newton block of copper sitting on a steel ramp at 35 degrees. Draw the ramp. Theta is 35 degrees. Draw the copper block, right? Cu. And this is steel. All right, hopefully you can do that step without any help from me. Will it slide on its own? Well, this is step 3, right? I got to start planning a solution. So what do we know from physics? Well, we're just going to try laying a free body diagram right on top of this little misadventure. There's our weight vector, right? So I will keep the black pen. Notice I have all my tools at the ready. I will try to draw a correct free body diagram. All right, and what opposes this motion would be this force of friction, right? And you remember that physics is fun, so you remember this equation. What else do I have? I've got the normal force, right? Which is the ramp pushing up against the block. That's why I don't go through the table, right? And I'm just going to pick up my red pen and just draw the component of the weight vector, which represents the opposite of force normal, right? That's a Newton's third law pair. Oh, look at all this midterm review you're getting auditorily. And that's W cosine theta. And then I pick up my green pen, and the we factor is caused by our little friend here, force parallel, and that's W sine theta, right? And that would actually show up as a real force up here on our diagram, right? That is the force that is tending when you get on roller skates or a bicycle on a hill. That is the component of your weight that is pulling you down the hill. So part A of this problem is, will it slide on its own? That's a traditional friction problem. You've got plenty of resources to solve that. The next part of the question is that teacher trick where they ask you just a little bit more. What's the maximum angle this can hold in a static scenario? So we did plenty of demonstrations where I would tilt the ramp and then something would slide. So where is that magic moment? Well, if it doesn't slide, that means friction is greater than force parallel. If it does slide, it means force parallel is greater than force of friction. So the sweet spot is when F of P is equal to force of friction. Right? So that's the maximum angle. And from here it's a substitution. Right? What is force parallel? That's W sine theta. Right? And what is the force of friction? Going back here, that's mu times, I'm going to pick up my W, my red pen, cosine theta. I could probably highlight that green, right? All right, I've done enough for you. That is problem 8. Let's see. I brought spares home since the copier made way too many for me. Oh, I did figure out that the copier was squaring the number of papers that I requested. All right, Mr. Russo has created a horizontal ski jump in his backyard. My wife and I just walked that trail. Caleb launches it on his snowboard. He lands 10 meters down the slope Mr. Russo measures the angle of the landing zone as 40 degrees, which is the steepness of your typical expert terrain at a ski area. What was his launch speed? Better get a picture of what's going on here. This is the key to this problem, right? So this is the part that's a little bit different for you. So here's the hill. It's coming down, hits the horizontal ramp, right? That's the jump. And then there's the slope. So there's our 40 degrees, or theta. There is Caleb wearing his helmet while he snowboards, right? No helmet, no ride. That's a Russo rule. We got to draw a snowboard. There we go. Right, what is this VI? That's the big question. So from here, many of you might be choosing option A, which is to lay down on the floor and cry, but there is no need, right? I measured, pick up my blue pen. I actually did this experiment. We did build a ramp and Caleb did snowboard, and you could clearly see where he left the ramp, right? And then where he landed, boom, it left a big mark in the snow. And that is the 10 meters, right? So usually I'm giving you the base or the height. In this case, I gave you H, right? That's your hypotenuse if we're playing the trig game. So what's hard on this problem is you have to dig out. Oh, I'm wearing, that's my red pen. It doesn't look very red on the screen when I looked. All right, what is this distance? All right, this is the adjacent side. A equals H cosine theta, right? You have the hypotenuse, you have the angle, you can find the length of that side, and correspondingly, you can work backwards to find this side as well. Right? I can then measure this. This is the height. Right? In trig terms, this is the height, or it's the side O opposite. Right? That's our H. And it's equal to big H, the hypotenuse, times the sine of theta. You have the measure of angle theta, you have the hypotenuse of the triangle. You can now find these two legs of the triangle, and I think you have enough skills to go from there. All right, number 10. Mr. Russo gets out his potato cannon. It's too cold today, I would not. He sets it up at 70 degrees and hits a target, the shed, 200 feet away. His wife shakes her head. Can he hit the coyote at the edge of the field 400 feet away? For ease, let's assume his backyard is flat. I can give you a picture if you need it. If not, what do you suggest he do with the potato cannon? If yes, what angle should he position it at? All right, so this is your teacher trick. Many questions in one. I better set up the first initial condition, right? Here's his potato cannon. It has some VI. It has a 70-degree angle. It launches a potato, and I hit the shed. And range equals 200 feet. One tick mark is a foot. All right. This is good because these are all things that I could actually go and do. I can measure an angle very easily, and I can measure where I hit very easily. So my hint to you on this problem is to use from your projectile equation sheet that the range equals VI squared sine 2 theta divided by G, right? We are looking for, using my green pen, we are looking for that VI, right? You've got the measure of the angle. We will assume that Nottingham is on Earth, and we know the value of G. And I've given you the range in feet. So that means you either have to have memorized, which I bet none of you have done, but G on Earth in feet is 32.2 feet per second squared. There you go. Working backwards, doing a little algebra, you can find that initial velocity, right? So obviously I can't set it at 70 degrees and hit the 400-foot coyote, or the coyote 400 feet away. So I've got to set it at some new angle. Well, I don't know what that angle is, but I know that the maximum angle for projectile, mathematically, is 45 degrees. So once I find that VI, set theta to 45, and find my new range. And the mystery is still afoot. Can I hit a coyote with my potato cannon or not? All right, over and out, physics fans. I will see you in class on Monday and Tuesday. And also take a look at the calendar, see what you think. All right, over and out.